Hey, hi everyone, welcome back to our daily LeetCode challenge series. So today is day 80 and today we are going to solve LeetCode problem 111 minimum depth of binary tree. So like it's quite similar to the yesterday's problem that we have solved. There we have to find the maximum width. Now this is the minimum width. So let's see the problem statement first. So we have given a binary tree, find the minimum depth. The minimum depth of the number of nodes along the shortest path from the root node down to the nearest leaf. Fine. A leaf is a node with no children. Fine. So here we have given the binary tree 3, 9, 20, 15 and 7. So minimum we can say, if we go the left side, this will be the minimum. So 2 is the max length we can say, right? So here we can see we are writing 2. In the example 2 we have similar way. So the minimum length that we can go is 5 in this case, right? Okay, so constraint we have given the number of nodes in the tree is in the range of 0 to 10 to the power 5. Okay, and the value can be ranged from -1000 to +1000. Fine. So we are going to solve it recursively only. Okay, so data will remain same. Let me remove that. Now what all base case we can consider here? Okay, so the base case is if our root is not equals to null, or we can say root equals to null, then we simply return that the minimum is 0, right? This is the base case. Second, we can say if root dot left is equals to null, and you can say root dot right is equals to null, then in that case, like base case, we have to find minimum, right? Then we can say it is 1, or we can use or here because we have to consider any of them. So let's suppose left side is null, then that means 1 is the minimum node that we can say, right? Minimum depth. So these are the two base case, right? Now other test case we can say, like first we'll move to the left side. Okay, so what we'll do here, we'll say if root dot left is not equals to null, that means there are some value at left side. So what we'll do, we'll call the recursively and find the minimum depth. So in order to do that, we have to store as well, like we'll take left and let's take integer dot max value, because we have to need minimum one, right? So similar way for right, we'll take integer dot max value. Fine. Now in the left side, what we'll do, we'll just check if minDepth, we'll call recursively, right? minDepth, my bad, minDepth, yeah, minDepth. Here we will pass a root dot left. Fine. And we have to consider the parent node as well, so that's why I'm doing +1 here, right? Similar way we'll do for right side as well. So we'll check here root dot right, if it is not null, then we'll just call recursively the right side and take out the minimum one. So let it be the right one. Fine. Now at last what we'll do, we'll simply return mat.max min, sorry, not max, mat.min, min of left or right. So whichever is the minimum, will that return directly, right? And +1 I have already given here, so we don't need to do +1 here to consider root node as well, right? Fine. So hope it will work. Fine, and let's submit and see. Okay, I think for one test cases it's got failed, one got passed. Let's see. if root dot left equals to null and root dot right null, then we're returning 1 here. Okay, I think it should be both condition. If both is like giving the correct, like both side is null, then only we have to return 1. So this is the base case, we can't give all, right? Fine. Now let's submit and see. Okay, yeah, we can see like both got passed now. Now let's submit and see other test case here as well. Okay, so all 23 test cases got passed. Its runtime is 64%. Fine. So yeah, if we talk about time complexity here, so we are iterating over each nodes of the given binary tree. So it is big of n, and minimum depth we can say it is like space complexity will be big of h, and h is the minimum depth. Here we can say, right, the amount of like height we are reaching, because we are like moving on both sides, left and right, and among that left and right we are picking the minimum one. So we are at least going to the depth of the binary tree, so it will be big of h. So yeah, that's all for today. Let's